Okay, so now we're going to talk about adding and subtracting radicals. The only radicals that we can add and subtract, they have to be alike. What does it mean for them to be alike? It means that the radicals have to be exactly the same, similar to like terms. So if I have 2 square roots of 3 and I'm going to add it to 5 square roots of 3, now I have a total of 7 square roots of 3, or 7 radical 3. Okay? Similar to 2x plus 5x equals 7x. Okay, now here, can I just add 2 different radicals? No. So let's prove it. So if we prove this, we said this was the square root of 25, which is 5. Is that equal to the square root of 9 is 3, plus the square root of 16 is 4. Is it equal to 7? No, that's not equal. So we just proved using an example that this is not a property that we have. So this is not true. So the point about all of this is that the radicals have to be the same. So here I have the radical 14 plus 9 radical 14. How many radical 14s do you think I have altogether? I have 1 plus 9 is 10. Just the same way that x is the same thing as 1x. If you have 1 radical 14, that's one of them, plus 9 more, and the radical stays the same. Just like the variables, we don't change anything about them. We're just changing how many of them do I have. Here I have 2 radical 12s. If I have to spend 3 of my radical 12s, how many would I have left? I owe 1 radical 12. Do I have to put a 1 in front of that radical 12? No, but it is implied that it's there, right? Just like there's a denominator of 1 as well if you want, right? These two, can I just add those two things together? No, they have to be alike. So in order to see if I could add them any further, I would need to simplify each one. So how would I simplify radical 8? I would do 4 times 2. The reason why I like the idea of just putting the 4 instead of 2 times 2 times 2 is then I can see that 4 is a perfect square, so that part becomes 2 radical 2. Does everybody see where we got 2 radical 2 from? What about the next one, radical 12? Square root of 12, 4 times 3. So that 4 comes out as a 2 while the 3 stays in. Can I add these now? No. This is actually fully simplified. We can't add because, what would you say why we couldn't add? Yeah, not like radicals. Which, similar, not like terms, very similar concept here. Okay, again, so we're going to want to look at this, and we cannot subtract these unless they have the same radical. So we want to simplify 54, 24. Okay, so 54, let's think about some factors of 54. And you might even start to look at your times table chart and think about, okay, which one of these perfect squares could divide evenly into 54? 9, yes, 9 times 6. So this is the square root of 9 times 6. And how will that simplify? Just the first one. 3 radical 6. No other perfect squares inside 6, right? Now we're going to subtract the square root of 24. So the square root of 24, what factors of 24 would you use? 6 and 4. Or I'll write it 4 and 6. I don't know. I'm writing this perfect square first because that's the one that's coming out. Maybe that helps. So the square root of 4 is 2. Square root of 6 stays in. And what do we get? Can we subtract them now? Now we can because they're alike. So what do we get? Yes, 3 minus 2 is 1. 1 square root of 6. You can put the 1 in front, or you can just write it as the square root of 6. Okay, you guys try a few practice problems, and then we'll go on to the next thing in the next video.